Alright, let's take a look at the notes from Chapter 2, Section 1, which is all about graphing and slopes. And so, first thing you need to remember is the slope formula. So the slope formula is just y2 minus y1 divided by x2 minus x1, and you probably have heard it mentioned as rise over run. So if we have a positive slope, it goes like this. All you have to do is pick out 2 points on there, and this one is rising, so as we move up we indicate that as a positive measurement, and then the next direction is to look horizontally, and from that point that we just rose we're moving to the right, which is also a positive quantity. And so the slope, we say, or the steepness of this, is just the rise divided by the run. Well, let's take a look at a negative sloped line, one that decreases as you move from left to right, and we'll pick out a couple of points on that one. A point here and a point here, and here let's show this going down first. So when you go down, you indicate that as a negative quantity. So our rise in this case is negative, and then we move to the right horizontally, which is indicated by a positive. So here we have a negative rise divided by a positive run, and one negative divided by a positive gives us a negative slope. And we use m as our variable for that. And going back to our first example, we had the positive slope, the red line here. We had the slope was a positive rise divided by a positive run. So two positives, of course, give us a positive, and that's why that slope is positive. Okay, let's take a look at our first example here, where we have the slope of y2 minus y1 over x2 minus x1, and it doesn't really matter which one you call x1 or which one you call x, or 0.2, but it is important that we note that these are our x and y coordinates. So we have an x and a y coordinates, and they gave us 2 of these. And just look at the relationship in the formula. Your y2, if you use that first to subtract, then you have to use the x2 on the bottom. So as long as you keep that straight and take care of your positives and negatives, you should be okay. So in this case, let's use 8 first. So if we use 8 first, that's y2. y1 would be 2. And we're going to use 4 for our run. And we're going to subtract it from a negative 6. So in the bottom we're going to add the opposite because we're subtracting a negative, so that's 10 over 6. So our slope reduces to 3 over 5. Okay, I'm not going to do the second and third problem just like we did the first one, but I do want to point out that when I look at my 2 coordinates that they gave me, 2 and a negative 3, and we got a negative 1 and a negative 3 for our second coordinate, you'll notice that our y's are exactly the same. So if you subtract a negative 3, subtract another negative 3, we expect that quantity to be 0. So in fact, anytime you see the y coordinates are identical to each other, you don't really need to worry about subtracting the x coordinates, because 0 divided by any number right here is going to give us 0. And 0 indicates that we're going to end up with a horizontal line. And so the opposite is true on number 3, where we look at our coordinates first and we see that the x values are the same. So going back to our formula, if the x's are the same, no matter what number you get on the top, you're going to have divide by 0 error on the bottom, which means that this slope is undefined, and it's going to create a straight up and down vertical line. So that's where the next section here comes in. They want you to show an example of a positive slope. In the next blank, a negative slope. A 0 slope, where m is equal to 0, is just a horizontal line. And if we have a undefined slope, it looks like this. Okay, let's take a look at the next example, where they want us to actually we're missing a spot here. That's okay, I'll do it right here. So the next thing that they have listed is that parallel lines, they want you to know the relationship with parallel lines. Parallel lines have slopes that are identical. So we have slopes that are equal. And for perpendicular lines, we have opposite reciprocals. So the slopes are opposite reciprocals. And let's take a look at a couple of examples of that. So if we had two lines, and line number 1 we'll do in blue, they gave you that it has an x and y coordinate, first point at 4, 1, and 7 and 2 for the second point. And they want you to look at another line and see if there's any relationship between it. So line 2 had a coordinate value of 1, negative 2 for the first point, and the second point had 0 and 1. So first thing we're going to do is just find the slope of each one of these. Notice that we have x1, y1, x2, and y2. So if we follow our formula, we'll use 2, subtract 1, and 7, subtract 4, and the slope of this is equal to 1/3. So let's go see what the red line gives us. We're going to have 1 subtract a negative 2, and 0 subtract 1. So to find the slope here, we're going to add the opposite, since so that gives us 3 on top. Oh, we're doing this one in red, aren't we? So we have 3 on top and a negative 1 on the bottom. So let's look at these two and compare them. Well, one's positive and the other one's negative. So they're opposite of each other. That's what we're talking about when we say opposite. And the second criteria is if they're reciprocals of each other. This is 1/3 and this one is negative 3/1. So since they're opposite reciprocals of each other, these two lines are going to be parallel. And of course we indicate, or not parallel, I'm sorry, perpendicular. We indicate perpendicular by this geometric symbol. So hopefully that'll get you started the right way on this first section, and we'll make another video for the next one.